Can we try our hands on using this sine rule and cosine rule to solve some problem and see how it goes? Right. Let's see this. Two forces, A and B, act at an angle 60 to each other. If A is 30 Newton and B is 40 Newtons, what is the resultant vector of A and B? Two forces, A and B, act at an angle 60 degrees to each other. 60 degrees to each other. If A, the magnitude of A is 30 Newton and B is 40 Newton, we are asked to find the resultant vector. Let's do this together and then you try your hand on one. First of all, let's try to sketch. So I have my cardinal like this. This is my north, south, my east, and my west. They didn't give me the direction, but they told us that the angle between the two are 60 degrees. So it means that if I put one of my vectors on the OX axis so that I'll be able to get my angle easily, then the angle between this vector and the one I'll draw should be 60. Remember, this O angle is 90. And so if I take 30 off the 90, I will get 60 here like that. So let me take this to be 60. That is 30. And this is my other vector. This is longer, so let me make this B, which is 40 Newton. And then that is my 30 Newton. Let me call this point O, A. Now over here, I will need to complete my parallelogram. I will need to complete my parallelogram. And by so doing, I have this. I believe you are also doing as I do. And then I have that. My opposite sizes has to be equal. So this is parallel to that. The top here is parallel to OA. So let me put B here and maybe C here. Then my parallelogram is complete. From here, what do we do next? We draw our diagonal. We draw our diagonal, and that is going to, of course, be our resultant. Having done this, then we come to ask ourselves, so now we don't have 90 degrees anywhere. Because of that, we cannot use Pythagoras theorem. So let's think of our functions, the sine function or the sine rule, the cosine rule. What does the sine rule say? What does the cosine rule say? Remember, this O angle here is the 60. However, the direction is just this small angle. From our cosine rule, we say that R squared is equal to, now remember this is R, so R squared, the angle that is opposite to R is this, A. So R squared is going to be equal to A squared plus B squared minus 2ab cos A. I hope you get that. From the cosine rule, our r squared is going to give us the sum of the square of the two sizes minus 2 by the two sizes cos the angle opposite to the side square that we are calculating for. Now, this means that we need to find the angle at A. How do we do that? Let's go back to angle properties. Can you see that the parallelogram OABC gives OB to be the diagonal? OB from here to here is our diagonal. At the same time, we can say that OA is parallel to CB. The line OA here is parallel to the line CB up there. And so the angle here, which is 60, is co-interior angle to the angle at A. This means that 60 plus the angle at A should give you 180, because we said that co-interior angles add up to 180. Our A then becomes 180 minus 60, which is equal to 120. So the angle here is 120. Having got the angle there, now getting our resultant becomes very, very easy. Why am I saying that? We're no longer going to say r square is equal to a square plus b square minus 2ab cos A. Now we can say that our r squared is equal to 30 squared. So our r squared, let me clean these ones so that we can write something there. Okay. So now we can say that our r squared is equal to 30 squared plus 40 squared minus 2 by 30 by 40 minus, cos 120. Our r squared is equal to 30 squared plus 40 squared minus 2 by 30 by 40 cos 120. We now have our r squared to be equal to 900 plus 1600 minus, when you have 2 by 40 by 30, that gives you 2400. And then our cos 120 also give us negative 0.5. I hope we are following. Good. So let's continue from there. We now have our r squared to be equal to, when you add 900 to 1600, what do you get? 900 to 1600, you get 2500. Good. 2500 And then when you multiply negative 2,400 by negative 0.5, that would also give you positive 1,200. This means that our r squared is equal to our r squared will be equal to 3,700. Finding r then means that we have to look for the square root of 3,700, which is giving us 60.82. I hope you got that. Great. At this point, we go for a very quick commercial break. When we return, we'll continue by looking for the direction. Well, welcome back. I believe during the break, you tried your hands on how to calculate for the direction. Let's see if what you did, you got it right. Before we went for the break, then we got a resultant to be equal to 60.82. We got our resultant to be equal to 60.82. And so we are going to continue from there. Our R was obtained to be 60.82 newtons. Okay. Let's put it there, 60.82 newtons. Now, in getting the direction, we can see clearly that our angle here, which is our direction, is opposite to the line AB and adjacent to the line OA. Do not also forget that the line AB is the same as the line OC, which is equal to 30 newtons. This implies that if we want to use the sine rule, which says that our R on sine A is equal to line AB on our angle theta, because the R is opposite to A, the R is opposite to A, and our theta is also opposite to the line AB. And so if we take R to be the line which is opposite to the angle of A, then we can also say that our line AB is opposite to the angle theta. So we can conclude that either sine of the angle A over R is equal to sine theta over the line AB. Or you can also say that the line R, which is the resultant on the sine of the angle A, is equal to the line AB on the sine of the angle theta. Now, what is our R? Our R is 60.82. and our A is 120. So we have sine 120. This is giving us our line AB, which is 30 Newton on sine theta. And so again, we'll clean some part. Okay, let's move to this point. So we can say that from where we have 60.82 on sine 120, giving us the line AB, which we say is 30 newtons. So the 60 point is also in newtons, and 120 degrees, that is sine theta. Right. From here, we can see that sine theta is equal to 30 sine 120 on 60.82. Therefore, our theta will give us the sine inverse of 30 sine 120 on 60.82. If you use your calculator, you will see that you are going to get your theta to be equal to 25.288. So we can just say it's equal to 25.3. How many of you got it right? Good. You just have to keep it up, and you just have to keep trying on more examples. The best way to learn some of these things and to keep them in your mind is to solve as many examples as possible. At this point, we'll open our phone lines so that you call through with your questions, your inputs. Let us hear from you. Let's know how you feel about this whole thing. Let's know how you feel about tonight's section. You can call us on 0302-211-698 or 030-22-11-699. 0302-211-698 or 0302-211-699. Let me hear from you. All right, so we continue. We have another example that I would like us to try. A particle has two velocities. A particle has two velocities. To 20 meters per second due east and 12 meters per second in the direction east of north, in the direction 30 degrees east of north. What is the resultant vector? A particle has two velocities. 20 meters per second due east and 12 meters per second in the direction 30 degrees east of north. What is the resultant vector? Let's try our answer on this. I'm giving you 2 minutes to try your answer on this. Then I'll join you as we solve it together. All right, so I think I have Ajeman on the line. Ajeman, welcome and good evening. Ajeman, can you tell me where you are calling from? Hello, Ajeman, can you hear me?
I'm calling from Amakom.
Ajeman, please lower your TV set and listen to me through your phone, please. If possible, move away from the TV set. Hello, Ajeman.
Yes.
Yes. You said where are you calling from? Ajeman, I hardly hear you.
Okay. Hello.
I'm with you, Ajeman. You let me hear you. Speak on.
Your call has been put on hold.
Oh, sorry. It seems Ajeman is having challenges with the phone. All right, so let's move on. Let's see how we solve this one. A particle has two velocities, 20 meters per second u is and 12 meters per second in the direction 30 degrees east of north. What is the resultant? So first of all, as usual, we try to sketch the motion. And so I have my okay, so we have north here like this, and then all right, I have Ebenezer. Ebenezer, good evening and welcome.
Welcome, sir.
Ebenezer, how are you?
Please, I'm fine.
Can you tell me where you are calling from?
Please, I'm calling from Takrady.
Great. So, Ebenezer, what school do you attend and what form are you?
Please, I'm in Form 1 and I'm in 10 GSTS.
Great. Great to have you here. Now, what do you want to share with me?
Please, when you get to the find of the direction.
Okay.
When you get to the sine inverse, finding the sine inverse.
All right, I'm with you.
Can't you, without using a calculator, can you solve it?
No. You see, with the sine is a function. It's a function, okay. So you always advise to use the calculator.
Oh, okay.
So first of all, are you with me?
Yes, sir.
So first of all, you solve the one in bracket, 30 sine 120 on 60.82. Then okay. Whatever that you produce, you find the sine inverse of that.
Okay.
Are you with me? So
yes, sir.
work with the one in the bracket first, and then after that, you find the sine inverse of whatever you get for the one in the bracket.
Okay, sir. Thank you.
Thank you too. Nice to hear from you, and my greetings to your physics teacher in school. Hello, Samson.
Hello, sir.
Good evening and welcome.
Good evening to you too.
Samson, tell me where you are calling from and the name of your school.
I'm calling from Zevila, from the East region of Ghana.
Wow. Great to have you, Samson. Samson, what form are you?
I'm in Form 1.
Great. Let me hear from you, Samson. What do you have to share with us?
Sir, you beginning with the cosine rule.
The cosine rule?
Yes, the first example that you did. I got lost a little bit.
Okay, so let's quickly look at the cosine rule again. With the cosine rule, we said that, are you with me, Samson?
Yes, I'm with you, sir.
We said that depending on which side you want to calculate, all right?
Yes.
You square that side. So for example, if I want to calculate for the side here, are you with me?
Yes.
Then it is the square of that size being equal to the sum of the squares of the opposite side, which is the A and the B. So we are going to get A squared, B squared minus 2 times the same A and B cos. Then, because I am looking for this C, I will find the cos of this angle here. Are you with me?
Yes.
So now let's move quickly to the solution that we did. So when you come here, you realize that we had from here something from here. Okay?
Yes.
We saw that our A here is 120 using angle property, saying that the 60 degrees we have here is co-interior to the angle here, so they will add up to 180.
Yes.
So after producing our 120 here, we now come and put it in this equation, having in mind that our A is 30 and our B is 40. All right?
Yes, sir.
Now, when you get here, please find the cos A separate. Don't make it 2AB cos A. Don't do that. Don't do negative 2AB cos A. Don't do that. Find your cos A and multiply it by negative A 2AB. Okay?
Yes, sir.
So please, I want you to sit back, try that again, and give me a feedback if possible.
Okay, awesome.
Thank you very much, and nice having you, Samson.
Okay.
All right. Mary, good evening and welcome.
Okay. Hello.
Hello, Mary.
Yes.
Mary, can you tell me where you are calling from and the name of your school and your form, please?
Please, my name is Mary, and I'm calling from Takoradi, and I'm in class 6. I just wanted to ask whether small kids can learn.
You want to ask whether... Please move away from your TV set.
Okay.
You want to ask whether what?
Small kids can learn or enjoy learning.
Yes, please. Yes, please. Small kids can also learn on Joy Learning. So just follow the timetable and know when we have the JHS section, and then you follow. All right?
Okay.
Nice hearing from you, and please make time with the JHS section, and then I hope you enjoy that as well. All right. Okay. Okay, I have Progress on the line. Progress, welcome and good evening.
Good evening, sir.
Progress, how are you?
I'm fine, sir.
Can you tell me the name of your school and your form, please?
I'm from Notre Dame Seminary Senior High. I'm in second year.
Right. So what do you have to share with us, Progress?
Sir, the trial question, I have the answer to that one.
The final question, you had the answer wrong. You
I
said
said I had the solution to the trial question.
yes. You had it correct.
I had the solution. You said we should try it. We haven't yet had the answer.
Okay, so what did you get?
I had the resultant to be 28 Newton and the direction to be 21.8 degrees.
Come again.
The resultant, I had 28 Newton.
Mm-hmm.
And then the direction, that one I had is 21.8 degrees north.
Are you talking about this question?
Yes, sir, the trial you give.
The one we have particles, a velocity with two particles, 20 meters due east.
Yes, sir.
Oh, okay. I think then with that, the solution you are giving me is not what I have here. So just stay back. Let us solve it together. And I hope you will see where you faulted.
Okay, sir.
But then when we are done and you identify where you faulted, I'll be grateful if you get back to me and give me a feedback.
Yes, sir.
Right. Thank you. Okay, so I have a caller on the line. Please, can you tell me your name and where you are calling from? Come again. Okay. All right, so let's solve this trial example. Let's solve this trial example together. and let's see what the answer is. Now, the first one says that the particle has a velocity of 20 meters per second due east. So when we say due east, we don't know exactly where in the east, but we know it is having 20 meters per second. However, we have the angle between the two vectors. The second one says that the second vector is 12 meters per second in the direction 30 degrees east of north. So let's get that one. The one which is 30 degrees east of north. Remember, east of north is around here. Okay, so I am drawing. Let me take my pen, and then I have this, and this is 30 degrees to the 30 degrees north of east. So I will have my 30 here, and remember the whole of this is 90. So if this is 30, then this becomes 60, so that I obtain my 90. Then I also have, and this is my 12, the one with 12 meters per second. And then I have another. I want to place that. I told you I like putting my other vectors on the OS axis so that I can easily find my direction. And over here I have my vector to be 10. 10. All right, so it means I have to make it shorter than the 12. So let me leave that one. Let me clean so that I'll make it shorter. Reasonable. So it has to be shorter. Okay, so I have that one 10. 10 meters per second. So let me complete my parallelogram. Let me complete it. I have 10. And then, okay, I have this. All right, so I have a caller on the line. Please, can you tell me your name and where you are calling from?
I'm Emmanuel. I'm calling from Tete.
Come again, you are who?
Emanuela.
Okay, Emanuela, where are you calling from?
I'm calling from Tete.
Where?
Tete, in the
Tete.
region.
Oh, okay. Emanuela, what form are you and what school do you attend?
I'm in first year and I attend Outdoor Senior High School.
Right. So, Emanuela, tell me what you want to send across.
Please, I want to say I don't understand this one very well. So I would like to solve more questions with us so that I'll get to understand.
You don't understand which one?
The sine and the cosine, I don't understand.
All right. All right, Emanuela. So, I'll go over the sine and the cosine rule once again.
Okay, thank you.
All right, thank you also for calling. And so, Emanuela, if you are listening, if you are watching, this is the sine rule. Now, one thing I want you to bear in mind is that it is a rule. So you try to abide by the rule. If you have a triangle like I have here, I'm saying that the angle here at A is opposite to this line. The angle here at B is opposite to this, and the angle here at C is opposite to the C. And so anytime you want to find any of the sides, the C over the sine of the angle at the C is the same as A over the sine of the angle at A, and is the same as B on the sine of the angle at B. If you get this simple rule, then all you need is your substitution whenever it comes to solving problems. Then when you come to the cosine rule also says that the same scenario, the area A here, the angle A here is opposite to the side A there. C is the same and B is also the same. So looking at one side, for example, C squared, it gives you A squared plus B squared. That is the square of the sum of the other two sides. Okay? Minus 2, and then the product of those same two sizes, which is A and B, then the cos of the angle of the C that you are looking for, which is big C. And so all you need is to just understand the rule and apply it. Please keep trying, and I believe the more you try, the more you get perfect. I have a caller on the line. Please, can you tell me your name and where you are calling from?
I'm Enoch from Cape Coast.
Enoch from Cape Coast. Enoch, what school do you attend and what class are you?
I'm in education. I attend Ugwasnya Technical School.
Which form are you, please?
From what?
Great. So let me hear you, Enoch.
Sir, like, how do you get there? Like, when you just get there, R square equals 30 square plus 40 square minus 2 times 30 times 40 cosine of 120 degrees. How do you got a 50.882?
You mean here?
Yeah.
When we have, for example, when we have our R squared equals what? 30 squared plus what?
40 squared.
40 squared minus 2 by 30
times 40
by 40
cos 120.
Cos 120.
You got 60.82.
Great. So let me ask you, are you with me?
Yeah, I'm with you.
Okay. So now let's look at something. If you have If you have 30 square, what do you get?
900.
I want us to do it together. If you have 30 square, what do you get?
900.
Good. And if you have 40 square, what do you get?
1,600.
Good. So now add the 900 to the 1,600. What do you get?
2,500.
You got what?
2,500.
6,500. You got 2,500. Oh, I lost him. Very bad. Please try and come back so that we get it. But then if you are listening to me, now when you get your 1,200, you also multiply your -2 by the 30 and the 40, which is going to give you -2,400. Then you find your cos 120, which is giving you -0.5. Now, multiply your -0.5 by your -2,400. That will give you +1,200. Then you add the +1,200 to the 2,500, which will give you 3,700. Find the square root of your 3,700 and you should be getting 60.82. Try that. If you get it, you can get back to me. Right. So we're trying to solve the example that our brother gave us the answer, which we said is not correct. And in solving that example, we said that we have two forces. One is 20 meters per second to the east, and then the other is 12 meters per second to the direction 30 degrees east of north. And so I was trying to get a sketch of that particular situation for you. And we are saying that over here we have our particle, which is 12 centimeters, and we know the direction. And so when you take the 12 centimeters, the direction of the 12 centimeters is 30 degrees east of north. And so we have this, and if you take this to be 30, I think it's too big. Let's increase the size. So if this is 30, oh yes, 30, let me get 30 from here. This is our 30, and this becomes 60. Okay. Now, so what I'm going to do right now is that, because of our time, I want to leave this with you. So my brother who solved it, please go back and look at it again. I'm leaving it with you. When we meet again, we'll definitely take it from here. Is that right? I believe by that time, you would have produced an answer. Otherwise, then I will guide you on how to produce an answer. Till then, I want to thank all of you for your time, and I believe that you have benefited a lot from today's section of our revision show. I urge you to make time all the time with us here, and together we'll make our revision interesting. For our Form 3s, continue to pay attention and take advantage of this program. Because like I said, when you breathe deep, you will smell the scent of wasi. Thank you very much, and thank you for being with me. Good evening, and it is a bye.